Hi, everyone. My name is McLean Wilkeson, co-founder and CEO of NuCypher. I'm here with Michael Agorov, our CTO. NuCypher is a security and encryption platform that's body armor for big data. We work with customers around three primary use cases: secure cloud enablement, giving large, highly regulated, security-sensitive industries like financial services a way to securely and compliantly move to the public cloud; secure sharing of sensitive data with third parties, vendors, suppliers, regulators, and helping companies comply with various data protection regulations like HIPAA, PCI, PSD2. The amount of data being generated today is absolutely staggering. Over 90% of the world's data was created in the last 2 years, and much of it is highly, highly sensitive. Businesses not only have to protect themselves, but they also have responsibility to properly manage and safeguard their customers' and users' data. Let's take an e-commerce retailer like Amazon as an example. From the moment you land on their app, you're generating hundreds of data points. What you're clicking on, what you're looking at, how long you're staying. All of that is ingested in real time, along with the details of any order you make. Your name, address, credit card number. That's analyzed for insights into your behavior as a consumer and aggregated with millions of other customer accounts. This explosion of data, along with the associated storage and computational demands, is driving much of the underlying IT infrastructure into the public cloud. Organizations are scrambling to stay agile and competitive, wanting to provision new servers and new services in minutes as opposed to the weeks or months it takes on-prem. But moving outside of the organization's four walls presents an entirely new set of security and compliance challenges. And while there's a huge ecosystem of security tools provided by both startups and incumbents, most of these tools are built for the past and are focused on the wrong problems. They promise to protect you from getting hacked in the first place, providing network and endpoint security to keep the bad guys out. But this is like the legend of the little boy plugging a crack in the dam with his finger. It might have worked when you had a small amount of data to protect, but now you have oceans of it. There are too many cracks, and you only have so many fingers. The bad guys will find a way in, around, or through your walls, and you will get hacked. And when that happens, your data is still secure with NuCypher. You need to embed security into the data itself, and that's where encryption comes in. But traditional approaches, although they provide security and protection, also come with significant performance and functionality drawbacks. They're like the original Iron Man suit hacked together with scrap metal in a cave, secure but bulky and unwieldy. NuCypher provides that same level of protection, but without the restrictions. Flexible, powerful, and secure, NuCypher is the Iron Man Mark 46 for your data. With our patented proxy re-encryption crypto system, NuCypher protects your data and follows it wherever it goes, both on-prem and in the cloud. NuCypher guarantees your data can be accessed only by valid users, and if an unauthorized or malicious attacker breaks into your system, all they see is encrypted gibberish. We can do this by embedding access controls directly into the encryption itself. Let Michael show you a demo of how that works in Hadoop and Kafka.
All right, so I will show you basically two features of our product, delegating decryption rights and granular encryption. So let's say we have a Hadoop cluster where we have user Mike owning some data. This is basically CSV time series data, and that's basically how it looks like. And this data is encrypted with a secret key of user Mike. Now this user wants to give access to user Hadoop to work on this data. If he doesn't do that, then basically user Hadoop pretty much cannot read anything, and he even doesn't have any ways to decrypt this data, even if he had root access to everything. So now user Mike creates something called re-encryption key. So he creates he allows user Hadoop to decrypt data encrypted with his key. Right, and so what happens after this? Our software will look at these policies and create something called re-encryption key. And this will allow the cluster to transform data encrypted under Mike's key to be readable by the key of the user Hadoop. And basically, if after this permission is given, when user Hadoop tries to decrypt this data, right, he actually succeeds. Well, not only this user just needs to read this data, he probably needs to analyze that. So let's say he runs some Hive query, and Hive also has access to this same data if it's working under this user's credentials. So let's just check that. Just waiting for Hive to finish processing. It's not the lightest thing. Yep, so it worked. Now let's see what happens if some unauthorized user, let's say some unauthorized user hacked into this cluster and, I don't know, used some zero-day exploit to get root permissions, something like that. So if that user tries to read that same file, of course he cannot decrypt anything, because even the root user doesn't have access to, doesn't have this decryption key. And if he tries to read everything directly from the file system, he will see the encrypted gibberish. So this is that attacker who breaks through all levels of protections. Then you have a new level of protection inside. Now let me show you the ability to encrypt the data granularly. In this I will show using an example of Kafka. So let's say we have messages, in this case in JSON format, which have multiple hierarchical fields. Here, we have one user creating these messages and the other user consuming those. So the user who creates the messages says, I want these messages to be encrypted granularly. I don't know in advance which user will have access to what, but I want to be to specify this policy at the most, at the finest level. And when he creates this message, it gets basically into the Kafka broker side. And importantly, the broker cannot read this message. So after that, a user who has access only to parts of these fields tries to read this message. And he gets the message, but one of the fields he doesn't have access to. So instead of seeing their clear value like here, he reads some encrypted message. And then he can obviously analyze the data he has access to, create new fields, push it back to Kafka, and what was encrypted just stays there.
Our founding team has worked at Morgan Stanley and built infrastructure tools at LinkedIn. Our CTO, this guy, is a former physicist and scientist from the Moscow Institute of Physics and Technology, who previously worked in an area closely related to quantum computing and cryptography. We're working with one of the leading proxy re-encryption researchers in the world, and NuCypher's technology is compliant with standards bodies like NIST and FIPS. We're incredibly excited to build NuCypher into the de facto security layer for the cloud infrastructure market. We've partnered with leading big data vendors and cloud service providers to accomplish this. We're also already proving it with major enterprises, both in financial services, telecommunications, and technology all around the globe. We're NuCypher, a security and encryption platform that's body armor for big data. If you'd like to come talk to us about how we can help your organization move to the public cloud, comply with data protection regulations, and securely share sensitive data with third parties, please come talk to us at our booth afterwards. Thank you. So some of the questions. How is PSD2 and GDPR affecting your company platform? So a couple pieces on this. One, we're working with a couple large financial institutions in the UK and EU around PSD2, and one of the requirements for PSD2 is to be able to give regulators real-time access to your data. So that falls under sort of partly, obviously, the data protection use case as well as the data sharing use case. So for PSD2, if you'd like to give regulator access to your Hadoop cluster, for example, you could create a special delegation or access token for that regulator, place it into your cluster, and then the regulator could use that delegation token to access your encrypted data. If for some reason you think that the regulator has leaked or one of their keys has been compromised, you can simply revoke that token and issue a new one. Also for GDPR, one of the benefits of NuCypher is that we remove the need to have your key management service and your data very close together. So you don't have this constant chattiness between the cluster and the KMS. So in theory, you could have a key management service that's in country. You could use a data center out of country. So for example, you generate data in Germany, you encrypt it in country, you keep the keys in country, and then you store it in a data center in the UK, for example. So we can address various data sovereignty concerns as well.
Right, so we also have an interesting question here. If we add decryption keys, aren't we increasing possibilities for data breaches? I think it makes sense to compare our technology with just having authentication. So let's say you have authentication with certificates, for example. You have multiple users having their pretty much key pairs, and they just use them to access the data. If somebody steals this key pair, they can authenticate, and same with our encryption. If somebody is granted access to, they can decrypt data using their keys. The difference comes basically to the system administrator. If you use just authentication or like authentication plus encryption at rest, then if somebody gets credentials of system administrator, they could get access to all of the data because system administrator user actually has access to all of the data, or root user. In our case, he doesn't need to have access to all of the data because he can just transform data to be encrypted for the other users. So you don't have this single point of failure. Imagine you have a multi-tenant data lake where different users have access to multiple slices of the data, but system administrator doesn't have access to anything at all. So you remove this one risk here. We have another question. Where are their encryption keys stored? So actually, we do support hardware security modules as well. So it doesn't. You could store keys, of course, in a database, but in a more secure environment, you would probably use HSMs. If you are root and you can change to mic user and then access the data, how can you prevent that? So basically, we protect if somebody hacks into that machine where the user mic is now working, of course, we kind of cannot prevent data leak in this scenario. Then the user basically who hacks into that machine can see in memory at least what user mic is doing. But if you have, let's say, a storage layer separated from everything else, nobody can basically get anything in the storage layer. Or if one user works on the slice of piece of data which he needs to work on, the attacker couldn't see anything else for all other users. And more than that, if attacker steals the key of the user who is delegated access to, that key will be actually useless once the permission is revoked, once the re-encryption key is removed.